Hey everybody, welcome back to CHALLENGEYOURSELF.BLOG. I've got a double update, so let's get started. So if you've been following along on my Twitter or LinkedIn page, you've seen some pictures that I've been posting periodically as I've been making some advancements in the robotics project that I've been working on. So first off, I want to talk about the gripper arm. So in the last video I talked about making a derivative of the original one, and as you can see I've got this torn apart because I was kind of reverse engineering it, and I wanted to customize it into a larger version for the arm that's in the background. It turned out really well. It's very sturdy. If I was to critique it, I would say that the gears are just a little bit off, and what I found from help in the Reddit community, they said that there's a tool in Fusion 360 for creating custom gears. So I haven't used that script yet. It was a little bit difficult to find since it's not readily, hey, here I am. You have to kind of find it, but once you found it, I'll show pictures of it on my blog. So one of the things that I've been finding as I'm learning to use the 3D printer is, as you can see, the teeth on the gripper arm are just a little bit crooked, and what that's from is when I was removing this from the support plate on the 3D printer, the knife would tend to bend. I was having a lot of difficulty with excess adhesion, which most of the forums and complaints that you find online are for the opposite problem, where you're not having enough adhesion. I was having a lot of difficulty getting the parts off the plate, so I ended up warping them. I managed to get most of them relaxed back into their original form. I could probably fix this. But it's not a deal breaker. It doesn't really hurt what I'm trying to do with this. I mean, it is basically a prototype, and it's for fun purposes. But overall, I'm really happy with the outcome of this. I haven't hooked it up to my Arduino Mega board because for the second update that I wanted to talk about, I kind of skipped ahead, and I'm making a robotic hand. So this is a finger, and as you can see, it actually is fully flexing. I actually made a custom ball joint so that it can move in all directions. And what's actually being printed right now is the carpals in the wrist where all of this connects. And as you can see, this is basically a lifelike model of the human hand. I was looking up a lot of references on the anatomy of the hand, basically the bone structure, tendons, ligaments, muscle structure, to basically model this. I've already seen some improvements that I would want to make in the next version of this. As I've been developing this, I've noticed a few things that I can still use this, and I don't think I'll run into too many issues with this, but if I was to remodel this, I have a few things in mind that I would do to improve this, but I'm pretty pumped about how this is going to turn out. I'm really optimistic in how this has gone together. I basically built this over a few days, and I've actually got 3 of them. So in this design, it might be a little difficult to see because the parts are black and the shadows are a little dark in there, but I've designed a lot of loops and holes in this. I even started off with kind of a center hole, a pair of them actually. And the original thought was I would have this kind of like an exoskeleton, like say, an insect's leg, for example. But as during this evolution of designing this, I'm kind of moving away from that and moving more towards the human anatomy and physiology. So I'll be probably following, using fishing line, actually, along the front of, like, the inside and the outside of this, and then I'll be using, like, the loopholes to run the line along the bone structure. And for tendon sheaths, I was thinking about using shrink wrap. I figured it would reduce the drag of the line, especially over, say, the knuckle joint areas. It would reduce the ability of the line to snag in places that you don't want it to snag. I've always been kind of fascinated with the human anatomy. Would have probably been a doctor, but I don't think I could have got through the dissection labs. A good friend of mine that was a roommate of mine in college, he took all of the anatomy and physiology classes, and he was always showing me cool stuff that he would learn in the classes and labs. So I'd kind of peruse through his books, and it was always really cool. I've had the good fortune of being able to go to a few trade shows that see how they design and build orthotics and prosthetics. So there's a lot of stuff from an engineering side that is really appealing. And as I'm going down the electrical and circuitry part of it, I'm starting to kind of dabble a little bit in a little bit of the medical side of things, since it's dealing with the human body, looking at electrical and circuitry, and then looking at mechanical properties. It's kind of a blend of all sorts of disciplines, and it's just a blast doing this. One of the interesting questions that I get a lot is, what is the purpose of the robot that I'm building? And honestly, I don't really have a set purpose for it. Basically, it's been kind of it's been about the journey and not so much the destination. So essentially, the purpose of the robot is, it doesn't know. I don't know. I don't really have a plan. I kind of have a long-term plan of things that I want to be able to accomplish. But I don't have a set route to get to that final destination, because it's still way out there. I don't know how practical it is to get to that destination yet. So I've been kind of segmenting the journey into a set of milestones that are somewhat vague, but also fairly practical. So for example, I started off and I wanted to make a little robot. So I bought this and I put it together, and I hooked up custom controllers to it, and I made it work. So that was kind of the first milestone. The second milestone was, what if I hooked that up to something like the rest of the arm and shoulder? But I didn't have that, so I was like, okay, I'm gonna have to build this. What am I gonna use to do it? So I started off with popsicle sticks. It was extremely cheap. It was very easy to by hand, just kind of hand drill holes into to make for shafts and collars and stuff. And when I bought the stepper motors, that was the next step. And how do I control the stepper motors? So that was kind of the next milestone. So as I was building that arm, the Raspberry Pi became kind of another ceiling that I was unable to control multiple stepper motors simultaneously beyond a certain number. So that became kind of the next hurdle. But with that, I was able to kind of look at, okay, well, where's the end goal at, and where am I here? And this is just like if you were taking a cross-country trip, you're driving along and, oh, I need a rest stop, or hey, I need a sandwich, or whatever. And that isn't planned. You're not like, okay, at 60 minutes I'm going to make this stop. You can do that, but sometimes, like if you have children or whatever, you're not going to be able to, go by the clock. It's, hey, I need food, I need to stop. And you have to make that, deviation in your plan. Same thing with this is I kind of got to where I was looking at where I'm at, and I'm like, okay, I'm over here, but I can still see the end goal. So accordingly, I'm making some course adjustments. Enter the 3D printer, and all of a sudden a whole bunch of doors and windows start to open up, and I'm able to custom build everything that I want. I don't have to go online and shop through a million different parts and try to figure out, well, I don't know if these dimensions right. It's like I can build them to whatever dimensions that I want, and it's perfect. So enter this. So I start building this, and I started thinking, well, I still want to make a hand, and that was a milestone that was a little bit further down the road. But because I suddenly had a technological leap in the tools that I have at hand, one of the milestones that looked like it was way out there suddenly was a lot closer. So I was able to make a course adjustment and say, well, I'm going to build this, and then suddenly I'm like, well, if I can build that, I can surely build this. And that's where I'm like, okay, I wonder how small of detail I can get. How fine of small holes and little bolts, and can I put the fishing line on here and make this work? And the further I go down the road, the more I see I can do this. I can make another small step. So you have small step change while making little course adjustments along the way, and occasionally you have a technological leap in the tool set that you have. And as I showcase this stuff online, people go, hey, that's really cool, have you tried this? And I'm like, oh, I never heard of that. So then I take that little piece of information, and I incorporate that into the projects that I'm building. And that's what makes this so much fun, and a community type project. One of the other things that fascinates me about this is I'm a lot further down the learning curve than I originally thought I'd be. I thought I'd run into a lot more roadblocks and problems, and I've had a few. I've like anything, I was talking earlier about how I had too much adhesion. All over the weekend when I was printing some smaller parts, I was having zero adhesion, and I was pulling out my hair. I don't have fortunately it's not long enough I can grab hold, but I was able to find some resources online that said, hey, if you use not only the supports but also rafts, you'll be able to get better adhesion. So with the smaller parts, I was able to group some of those up, cut down the time, use a little bit more material, but it's not a burden on the system, and it didn't really add that much time to it. So that's one of the things where a few small tips that you pick up gives you a huge leap. You run into a small roadblock that is slowing you down, and then suddenly the answer hits you, and boom, you slingshot 3 steps further than you thought you'd be. So basically I've learned a lot, and I've learned a lot faster than I expected I would. And I think, and because it's so much fun, it's kind of an incentive to keep striving forward. Each little success incentivizes you to take another step and keep moving forward in the same general direction. And that's how you get to those milestones. So you can look at all of those milestones and achievements that you've been making on your projects and divide them up and kind of look at, okay, here are the course corrections I've had to make. Was the information at the time indicating a problem that I ran into, and could I have avoided it? It's kind of through that reflection that you can better set yourself up for success further down the road. So I know this is kind of deviated a little bit from the robotics project, but it's kind of my thinking process as I'm doing this. I kind of try to explain how I get where I'm at. So anyway, I've been very thankful to everybody that's been supportive online. They've with all the ideas and comments and everything. So thank you very much from all the communities that I've been reaching out to. So anyway, that's what I wanted to kind of update everybody on. As soon as this thing comes off the printer and I'm able to get everything assembled, I'll have another update on the channel. And if you like what you saw, hit the like button, hit the subscribe button, and if anything, share this video. Thanks, and talk to you soon.